The year was 1982. Personal computers were still in their infancy. A small company called Commodore released a machine that would change everything. The Commodore 64. At the core of this revolution was the MOS 6510 microprocessor. This little chip, with its 8-bit architecture, became synonymous with a generation of gamers and programmers. The 6510 wasn't just a processor, it was a gateway. It opened up the world of computing to millions. Its simple design and accessible price point made it a favorite among hobbyists. Countless lines of code were written for this chip. Games, applications, and even early operating systems sprang to life, all thanks to the 6510. But time marches on. Technology advanced at an astonishing pace. The 8-bit world of the 6510 began to feel limited. What if, we asked, we could breathe new life into this legendary chip? What if we could bring it into the modern era of computing? That's where the idea of a 64-bit 6510 emulator was born. A crazy idea, some might say, but an exciting one nonetheless. The challenge was significant. How do you take an inherently 8-bit architecture and scale it to 64 bits? The answer lay not in physically modifying the chip, but in reimagining its core instructions. We carefully analyzed the 6510's instruction set. Each instruction was examined for its underlying logic. Then, we painstakingly translated that logic into a 64-bit equivalent. This wasn't a simple one-to-one mapping. The 6510's architecture, while elegant in its simplicity, presented unique challenges. Memory addressing, for example, had to be completely re-engineered. We had to ensure backward compatibility. The goal was to create an emulator that could not only run existing 6510 code, but do so with the power of a 64-bit system. It was a meticulous process. Countless hours were spent debugging and refining the code. But slowly, surely, the 64-bit 6510 began to take shape. This wasn't just emulation, it was digital archaeology, carefully uncovering the past and rebuilding it for the future. With the 64-bit architecture in place, we turned our attention to the visual experience. The Commodore 64, with its 320 by 200 resolution and 16 colors, held a certain charm, but we wanted to push the boundaries of what was possible. Our goal was to create an emulator that could render classic Commodore graphics in stunning 1080p resolution and beyond. To achieve this, we turned to GLSL, or OpenGL shading language. GLSL gave us the power to leverage the graphics processing unit, or GPU, for rendering. This allowed us to create complex shaders that could mimic the look and feel of the original Commodore graphics while enhancing them for modern displays. The result was breathtaking. Classic Commodore games, once confined to the limitations of a CRT monitor, now burst to life in vibrant high definition. Colors were richer, sprites were smoother, and the sense of nostalgia was palpable. But we didn't stop there. We wanted to explore the true potential of a 64-bit 6510, so we took on the ambitious task of integrating POV-Ray, a powerful ray tracing engine, into our emulator. Ray tracing, known for its ability to create photorealistic images, seemed like an improbable pairing with the 8-bit world of the Commodore 64. But the results were nothing short of astounding. Imagine classic Commodore sprites rendered with realistic lighting, shadows, and reflections. Scenes that were once pixelated and abstract took on a new dimension, their simple forms transformed by the power of ray tracing. This wasn't just nostalgia, it was a vision of the future, a testament to the enduring legacy of the MOS 6510. The 64-bit MOS 6510 emulator is more than just a technical achievement. It's a bridge between the past and the present, a tribute to the pioneers of the home computer era, and a testament to the boundless possibilities of technology. It's a reminder that even the most humble of beginnings can inspire innovation that transcends generations.